Hi again, everyone. Welcome back to our course in college algebra. In our last couple of videos, we had discussed the techniques of transformations to graph functions. Now, the functions we had been working with were the functions in our library of functions. You remember there were 4 graphs that I asked you to memorize. It was the graph of the absolute value function, which was a V shape, the graph of the squaring function, which was a U shape called a parabola, the graph of the cubing function, and the graph of the square root function. In this video, we are going to look at just generic functions. So in this problem here, I've just given you the graph of a function. Now remember, that is enough. If you look back to some of the first videos we did for this course, we can read the inputs and outputs off this function. You plug in 3, you get 1, right? Because 3 comma 1 is on the graph, okay? So all we've got is this graph. Don't know the formula. But we can still do some stuff with this. So given that graph below, let's do this. We're going to graph y equals, let's make it f of x plus 1 minus 3. Okay, so f of x plus 1 and then a minus 3 on the outside. All right, so let me just kind of walk through what I'm seeing here. Okay, let's look at the changes here on the input. So the changes to x were x was replaced by x plus 1. So what we're going to do is we're going to do the opposite of that to the x coordinates. And over here, that change, that's going to affect the y coordinates. Okay, so anything you do to the input of the function affects the x coordinates, because graphically the x coordinates represent the input to the function. So you change the input, you change x. You change the output, you change y. Okay, and I also want to make a quick list here of some anchor points. Okay, some anchor points on this graph. So negative 2 comma 0, 0 comma 3, right, that's negative 2 comma 0, 0 comma 3, 2 comma 3, 3 comma 1, 4 comma negative 1, and finally 5 comma 0. I didn't really need to do all this, but I think it'll be helpful. Okay, so let's go ahead and get to work on our new graph. So I'm going to draw myself a nice grid. Be very careful to draw things nice and accurate. Okay, so we've seen these type of changes before. We know how changing x to x plus 1 affects the graph. It moves the graph 1 unit that way, 1 unit to the left. And the minus 3 is going to move the graph 3 units down. Okay, so this point here, which is negative 2 comma 0, 1 unit left, 3 units down. So I was originally at negative 2 comma 0, 1 unit left, 3 units down. Okay? This point right here, 0 comma 3, 1 unit left, 3 units down. 2 comma 3, 1 unit left, 3 units down. Okay, now what we do is we're going to need to move all the corresponding parts of the graph too, right? The anchor points just give us like the skeleton, okay? Let's do this point. Okay, this point is 3, 1. 1 unit left, so now I'm at 2, 1, and then 3 units down. 2, negative 2. This is 4, negative 1. 1 unit left, 3, negative 1. 3 units down, it's 3, negative 4. Let me give myself a little extra space. 3, 1, 2, 3, 4. And lastly, this guy, 5, 0. 1 unit left, 4, 0. 3 units down. 4, negative 3. Okay, and we'll connect all those. Okay, so notice what we have here. Let me highlight it in blue so we can kind of see the distinction. From the axis versus the graph. Okay, so notice, exact same shape, we've moved 1 unit left, 3 units down on all these points. Okay, now, for something that we do a little bit later, I want you to get in the habit of looking at the change made to the x and doing the opposite of that to the x coordinates. Okay, so let's think about the new points that are now on this graph. Right, we started out with negative 2, 0. We're moving 1 unit left, so we're starting with this x coordinate and subtracting 1. That was what I was meaning when I said do the opposite. X got changed to x plus 1, do minus 1 to all the x coordinates. So the new x coordinate is negative 3. And then do this exact thing to the y coordinates. So instead of negative 2, 0 being on our graph, it's negative 3, negative 3. 0, negative 3. 1 unit left, subtract 1. Negative 1. 3 units down, 0. Same thing here. 1 unit left, subtract 1. 3 units down, 0. 1 unit left, 3 units down. 1 unit left, 3 units down. 1 unit left, 3 units down. These are the new positions of all the anchor points. And we got those by starting with our original anchor points and doing the opposite of this to the x coordinates. You replace x with x plus 1, do minus 1 to all the x coordinates. That's what you do with the x's. This out here tells you what to do with the y coordinates. Okay, so as long as you've got some points on the graph, you can do these transformations. You don't have to have a formula for the graph beforehand. You don't have to have the function's formula. All you need is the function's graph. And you can apply transformations to get new graphs that correspond to changes to that function.